It's Darasa Online again, and we'll be discussing about advanced mathematics. The topic will be algebra, and specifically subtopic will be matrices, and you will be with me, Kimati John, a teacher from Jangwani Secondary School. So be with me from the start of the session up to the end so that you can understand what we'll be talking about. Okay, to start with, we shall cover the following. We shall check, or we shall remind ourselves on the determinant of 2 by 2 matrix, and then we shall check the inverse of the 2 by 2 matrix, and then after that we shall check the determinant, or we shall discuss the determinant of 3 by 3 matrix, and then its inverse, the inverse of 3 by 3 matrix, and then we shall use the matrix method to solve a set of equations using the inverse method. So be with me. Okay, now let's discuss the determinant of a 2 by 2 matrix, and then after that, when I explain a determinant of a 2 by 2 matrix, I will also explain how to find the inverse of a 2 by 2 matrix, so as to remind you. Now, for example, there we have find the inverse of the following matrix, and the matrix goes by the name A, with the elements A, B, C, and then D. We are told to find the inverse of that matrix. Now, in order for you to find the inverse of that matrix, first of all, we must have a determinant. And how do we find the determinant of a 2 by 2 matrix? Let's have the tips there. And the tips there tells us, first of all, find the determinant, then after that you shall multiply a certain thing there. Now, in order for you to have the determinant of a 2 by 2 matrix, and it is abbreviated like that, you must have the product of the leading diagonal. That means the product of the elements in the position where A is and the D is, and then you will subtract with the product of the elements that are found in the main diagonal, that is to say B and C. That means you must have the difference of those two, that is so called the determinant of a 2 by 2 matrix. And then to have the inverse, you must have the following. Then multiply the reciprocal of the determinant. The determinant you obtain there, you have to reciprocate it. You have to reciprocate with the matrix of the following nature, and that nature is, you first exchange the positions of the elements that are found in the leading diagonal. Where A was, D comes there, and where D is, A goes there. That means that diagonal exchanges position, and the elements in the main diagonal exchange sign. If it was negative, it becomes positive, and if it is positive, it becomes negative. Then after that, you multiply the two, the reciprocal of the determinant, and then with the matrix of that nature that you found there. Then the product from there will be so-called the inverse of the matrix A. Okay, after reminding ourselves on the 2 by 2 matrix, the determinant and its inverse, let's use that knowledge to find the determinant of a 3 by 3 matrix. Why have we reminded ourselves on a 2 by 2 matrix? Because we shall use that knowledge to find the determinant of a 3 by 3 matrix. So if we have a matrix of that name, a matrix A, and we are given that matrix, and we are requested to find the determinant of that matrix, and the matrix is A with element A, B, C, D, E, F, G, H, and I, then how can we find the determinant of that? First of all, remember the pattern to use. Remember the pattern to use, and then after that, we shall have the following. We shall have the determinant of A. We shall have the determinant of A that is found with that pattern. Okay, let's see. The pattern is positive, negative, positive, negative, positive, negative, and the positive, negative, positive. So this is the pattern to be used, and the elements from the matrix are A, B, C, D, E, F, G, H, and I. So that those are the elements. Now let's see the determinant of matrix A. Sometimes in other books they write like determinant of A, or in other books, or sometimes it is written the determinant of A. So let's see how can we find the determinant of that matrix. Now remember, the pattern we'll use is that pattern. Now in this pattern you can choose. You can choose those signs from, or you can use those signs, or you can use them diagonally. You just choose, or you can use those ones. You just select one pattern. And remember, if you you choose that row, so remember to use the row entirely. And if you use that column, remember to use that column entirely while you find the determinant. And we shall see that when we are doing some few examples later. Now, let's use that row. And we shall see that the pattern there says it is positive. And this positive, we take the element from the first row, first column, and that will be A times the determinant of 2 by 2 matrix. And if we take that element there, that means where A is, the row and the column goes. That means we shall be left with that matrix there, a matrix E, F, H, and I. We go on. We have a negative sign. That means we shall have a negative sign there. And going to that way, that means we shall take a B, an element B, and multiply with. So if, as I said earlier, if I take the element B, that means the row and the column of where element B is goes. Then we are left with the elements or the matrix, a 2 by 2 matrix, that is D, F, G, and then I. And then going back to the pattern, that is plus, and then we are taking a C times what? And as I used earlier, that means the column and the row goes. That means we are left with D, E, G, and then H. Now, finding or manipulating that expression there, the answer you will obtain will be called the determinant of the matrix A. Now, to simplify that more, that means we shall have A times what? We know that the determinant of a 2 by 2 matrix is equal to the leading diagonal, that is E, A, I, minus H, F, minus B. Then we have D, I, minus G, F, plus C, then D, H, minus G, E. So if you manipulate that, the answer that is obtained there is called the determinant of A. Now let's see the example. Let's see one example. Example number one says, number one says, find the value of as you have seen there, 1, negative 1, 2, 1, 2, 3, 3, 1, 2, and it is in that form, and we've been told to find the value of that. That means this, remember, these signs do denote the determinant of a matrix. This denotes the determinant of a matrix. And how do we do that? Remember the pattern that I did explain. We have the pattern that is positive, negative, positive, negative, positive, negative, positive, negative, positive. So you will use this pattern in your solution. So let's do that. Now let me call this matrix by the name of C. That means we are going to find the determinant of a matrix C. And let's see. That means we have the determinant of C. And remember to use the pattern. So if we try to use this row, that is to say we are going to have 1, and the matrix that is left will be 2, 3, 1, 2, and then going to that part, we have a negative from the pattern, and we have another negative from the number in that point, and then we are left with 1, 3, then 3, 2, and then after that, from the pattern we have a positive, and there we have a 2, and then again we are left with 1, 2, 1, 2, 3, 1. So we have to manipulate that so that we can have the determinant to that. Now let's do that. So we have 1, this time that is 4, this time that is equal to 3, this times that is positive, that means is plus 1. And then this times that is equal to 2. This times that is equal to negative 9, minus 9, because you are supposed to subtract there. Then plus 2, 1, then that is 6. Then let's finalize that. We have the determinant of the matrix that I call the C will be 4 minus that one is 1 plus that is negative 7 plus this one will be we have a negative 5, then times 2 is a negative 10, that is going to be a negative minus 10. Then this plus that one, that is negative 6, and that one equals to negative 16. That will be the determinant of the matrix C. Okay, now we have been told to find the inverse, and the inverse of the 3 by 3 matrix is found by in order to obtain the inverse of 3 by 3 matrix, the following steps should be followed. First of all, we shall find the determinant of the 3 by 3 matrix, and then you have to determine the cofactor of the matrix, and then after that you have to determine the adjoint of the matrix, and we shall determine the adjoint of the matrix, and I will explain what the adjoint of the matrix. And then after that, to obtain the inverse, you have to multiply the reciprocal of the determinant times the adjoint matrix that you obtained above there, and I will show you how to obtain those. Then we have some abbreviations there. We have a raised to negative 1, that stands for the inverse, and then we have adj of a, that stands for the adjoint matrix of a, and then we have absolute value of a, that stands for the determinant of the matrix A. Now, my dear student, let's solve one example that requires us to find the inverse of a matrix, and the inverse, and that matrix is, the example requires us to find the inverse of a matrix, and we are given a matrix there. And the matrix given is so this is the matrix that is given from the example, and we are told to find the inverse of that matrix. How can we find the inverse of that matrix? Now let me give the name to this matrix. I will call this matrix matrix B. So let me find the inverse of matrix B. The first step, as the first slide before this said, we have to find the steps are, we have to find the determinant of that, then after that we have to find the cofactors, and then we have to find the adjoint matrix, and then we have to multiply the adjoint matrix and the reciprocal of the determinant. Now let's find the determinant first. That means determinant of B is equal to what? Now remember the pattern. This is the pattern. Let me use the second one. So let me use this one. Now it will be negative. I'm going to use this one. That means it will be 1. And the matrix that is left from there, that means this column and that row goes. That means we are left with 1, 1, 3, negative 2. And then times what? Times what? There is plus. But here we have a negative 2. Remember that? And we are left with what matrix? A 2 by 2 matrix that is left. Covering that 2 there, that means this and that goes. We are left with 4, 1, 3, negative 2. Then minus 1. Remember that's a negative. Then we are left with the matrix. This and that goes. We are left with the matrix 4, 1, 3, 3. Now let's finish that. It will be a negative 1. Remember the determinant of 2 by 2 matrix is found by the difference between the product of the leading diagonal minus the product of the main diagonal. That we have 2 minus 3. Positive times negative is negative. There we have a negative 8 minus 3. A negative and a negative is positive. 3 times 4 is 12, and 3 times 1 is 3. Then we have negative 1, negative 5, minus 2, negative 11, plus 1, there we have 9. And then there we have positive 5, and there we have plus 22, and then plus 9. Summing this, we have 27, then 36. That means the determinant of matrix B is 36. Now remember this determinant. Let's put it there. Our board is a little bit small. Now we have the determinant that is 36. Determinant that is 36. Now, after having the determinant, the second step is to find the cofactor, the cofactor matrix, the matrix of cofactors. And I will denote the matrix of cofactors by this, so that as I can know the positions of those cofactors. A1, 1, that means the first row, the first column. And then we have A1, 2, A1, 3, A2, 1, A2, 2, A2, 3, A3, 1, A3, 2, A3, 3. So that I can understand the position of the cofactors from that matrix. So that I can understand the position of the cofactors from that matrix. Now, when I say A1, 1, what do I mean? I mean the element, the cofactors of that element. And the cofactors of that element will be the matrix or the determinant of 2 by 2 matrix that is left after covering that the element from that position. Now let's see. The determinant of, that means we are left with negative 2, negative 1, 3, negative 2, and we can find the determinant to that equals to 4, 2 times 2, negative 2 times negative 2 equals to 4, minus 3 times negative 1 is negative 3, and that is, if you manipulate that, is 7. That means A1, 1 equals to 7. Now let's see A1, 2. A1, 2, that means we are at that position. That means that column when that row goes, we are left with 1, negative 1, and then 3, negative 2. Then the determinant to that is negative 2 minus, then we are left with negative 2 plus 3 equals to 1. That means A1, 2 equals to 1. Now let's go to A3, A1, 3. That means there, A1, 3. That means it is the determinant of 1, negative 2, 3, 3. 1, negative 2, 3, 3. Which equals to what? 3 minus 6, and that is 9. A1, 3 equals to 9. Let's go to the second row, that is A2, 1. The cofactor of A2, 1. That means we are there. That means covering that part, we are left with 1, 1, 3, negative 2. 1, 1, 3, negative 2. Now let's manipulate that. It will be negative 2 minus 3, and that equals to negative 5. That is a 2, 1. A 2, 3, that means a 2, 2, that means we are there, negative 2. We are left with 4, 1, and 3, negative 2. Then the determinant to that is negative 8 minus 3, which equals to negative 11. A2, 3. A2, 3, we are there. That means we are left with 4, 1, 3, 3. That means it will be 12 minus 3, which equals to 9. A 2, 3. A 3, 1. A 3, 1, we are there. That means it will be 1, 1, negative 2, negative 1. It will be negative 1 minus 2, negative 1 plus 2, which equals to 1, that is a 3, 2. A 3, 1. A 3, 2 will be equal to what? A 3, 2, that means we are there. That means we are left with 4, 1, 1, negative 1. Negative 4 minus 1, which equals to negative 5. A 3, 3 equals to what? A 3, 3 equals to what? We are there. That means negative 4, 1, 1, negative 2. 4, 1, 1, negative 2. So 4 times negative 2 is negative 8 minus 1, which equals to negative 9. But remember, the pattern was the first cofactor is supposed to be multiplied by plus. That means by positive. The first cofactor is supposed to be multiplied by positive. That means it is positive, and it is positive there. And that the second one is supposed to be multiplied by negative. That means there it was supposed to be multiplied by negative. So all of these were supposed to be multiplied by negative, and that is negative there. And then we have the third one is supposed to be multiplied by positive, and it is positive. And the fourth one is supposed to be the fourth one is supposed to be multiplied by negative. That means a negative there. And then all of this is supposed to be a negative. That means we shall have a positive 5. A positive 5. And then this one is supposed to be multiplied by positive, and it is positive there. Then it changes nothing. And then we have at that position, that is 2, 3. It is supposed to be multiplied by negative, and all of these is supposed to be multiplied by negative, and that is negative 9. And at that position there, it's supposed to be multiplied by positive, and it changes nothing. At that position, it's supposed to be multiplied by positive, by negative. At that position, it's supposed to be multiplied by positive. That means it will be a positive. And at that position, it is supposed to be multiplied by positive and it changes nothing. Now, to have a matrix of cofactors, then we have to collect all of these cofactors from A11 up to A33 as that matrix shows there. Now let's collect them. And remember, the determinant was 36. Now let's collect the cofactor matrix. So the first one is 7, and that one is -1, and that is 9, and what is that is 5 at that position, and at that position 2, 2 is -11. At the position 2, 3 is -9. At the position 3, 1 is 1. At the position 3, 2 is +5. At the position 3, 3 is -9. And the next step, after you have already find the matrix of the cofactors, is to find the adjoint matrix. And the adjoint matrix is the transpose of this matrix. And when we say transpose of this matrix, we mean the columns becomes the rows and the rows becomes the columns. That means let's find the adjoint matrix of B. Now, if we transpose this, it will be the cofactor Therefore, if we transpose this, we shall have the adjoint matrix, adjoint of matrix B, which equals to what? 7, -1, 9, 5. That means this row has become the column, and then this one will become that column. -11, -9, and this will be there 1, 5, and this will be negative. Then, if this is the adjoint matrix, what is the inverse of B? And we say that the inverse of a matrix will be found by the reciprocal of the determinant. That means the determinant of B times the adjoint of B times the adjoint of B. Now, it implies that there is 1 over 36. Since our determinant is 1 over 36 times what? Times the adjoint matrix, and that is 7, 5, 1, -1, -11, 5, 9, -9, -9. And what will be the inverse of the matrix B? Let's check it out. Let me have that means the inverse of matrix B will be 7 over 36, 5 over 36, 1 over 36, then -1 over 36, -11 over 36, 5 over 36, and then 9 over 36, which we know is 1 over 4, and that will be a -1 over 4, and the last one will be a negative of 1 over 4. So, my dear student, this is how we find the inverse. First of all, you have to find the determinant, and we did that. We found the determinant, and then after that, we started finding the cofactors. The cofactors, from there up to that point, we did find the cofactors, and then, but remember when you are finding the cofactors, remember the pattern and the position of those cofactors. Then after that, we did have the cofactor matrix, and we collected the cofactors to this matrix. And then after that, we had to find the adjoint of the matrix, transposing this matrix, and then we had this. That means this is the matrix of adjoint matrix and the adjoint of matrix B. And then after that, we multiplied the reciprocal of. Then after that, we multiplied the reciprocal of the determinant times the adjoint of B, and this was the result that we obtained. So this is the inverse. This is the inverse of the matrix B. Follow the procedure, and I assure you, you will get the answer. Now let's see how can we solve. Now let's see how can we solve the set of equations using the matrix method. My dear student, solving a set of equations using the inverse method, you must follow the following procedures. Given the system of linear equation and requested to find the solution to that, then use the following steps. And what are the steps? Let's see. Write the equations in matrix form. So you'll be given a set of equations, and then write that into matrix form. Then the second step is find the inverse of the matrix, and then we shall see what matrix are we supposed to find the inverse. Then the third step is pre-multiply the inverse of the matrix, both sides of the equations. We shall see how shall we multiply that, and then evaluate the inverse, and then evaluate the values of the variables of the system of the equation, and then evaluate the value of variables of the system of the equation. Now, my dear student, let us solve the system of linear equations as we are given there. Now, example says, solve the following system of equations using matrix method. How can we solve that? So we are given x plus y plus z equals to 3, 2x plus 2y minus z equals to 0, x plus 3y minus 2z equals to 15. Why have I decided to use a z like that? Because I don't want to confuse a z and a 2. Now, the first step, as we discussed in the last slide, was write the system into a matrix form. Let's do that. So collect the coefficients of the equation. That will be 1, 1, 1, 1, 1, 1. The coefficient of the second equation is 2, 2, negative 1. And the coefficients of the third are 1, 3, negative 2. And the variables are x, y, z. And on the right hand side, we have 3, 0, 15. So the first step is done, writing the equations into matrix form. And then the second step says, you have to find the determinant of the matrix. And the determinant of the matrix we are going to find is the determinant of this matrix. The determinant of this matrix. And the determinant of the matrix we are going to find is the determinant of this matrix down here. Now I will call this matrix by a name C. Now I'm supposed to find the determinant of the matrix C equals 2. Now remember the pattern. I will write the pattern here. That will be used to find the determinant and then the cofactors. We have positive, negative, positive, negative, positive, negative, positive, negative, positive. Now I will use this one. So we have a positive, and then we are taking 1, and the determinant of a 2 by 2 matrix that is left after covering that 1, we are left with 2, negative 1, 3, negative 2, then minus 1 is there. Remember when I reminded you about how to find the determinant, and then we are left with 2, negative 1, 1, negative 2, and then we have 1, but remember it is positive from the pattern, and then we are left with the 2 then again, and then 1, 3. Now let's find the determinant to that. So it will be 1, and then the determinant of 2 by 2 matrix is 4 minus 3 minus 1, and then we have negative 4 minus 1, negative 4, negative 1, the difference of that, then plus 1, and we have 6 minus 2, and then we are left with 1, 4 plus, remember it's negative 4, minus 1, and remember that is positive, that is 4, plus 1, plus 1, and that is, if we subtract, it will be 4, and then we are left with, there inside will be negative 1, and there inside also will be negative 1. That means we are left with what? We are left with the negative 1, and negative 1 times negative 1, we are left with a positive. Okay, there inside will be negative 1, and there will be negative 3, and there will be 4. Then there 1 times negative 1 is negative 1. Negative 1 times negative 3 is positive 3, and then 1 times 4 is 4, and then we are left with what? There will be 2, and then plus 4 is 6. That means the determinant of the matrix C is 6. The determinant of that matrix is 6. Then after that, we have to find the inverse. Now, finding the inverse, as we discussed the area, we know the steps. We have to find the cofactors, the cofactor matrix. Now, I will use that part to find the cofactor matrix. And remember, there will be A11, A12, A13, A21, A22, A23, A31, A32, A33, A33, and those are the position of the cofactors. Now let's see. Let's start with A11. A11, we are talking about that part, and remember the pattern is positive. We can multiply with the pattern directly. Then we have the positive that we are left with 2, negative 1, and then 3, negative 2. And then this equals to what? The determinant to that equals to negative 4 minus 3, which equals to minus 4 plus 3, which is equal to negative 1, A11. And A12, we are talking about that position, that means there. That means covering that part, that means this column and that row goes, we are left with 2, negative 1, 2, negative 1, and then 1, negative 2, 1, negative 2. And then this will be negative 4 minus 1, that is positive. That means we are left with negative 3. But remember, the pattern says that is supposed to be a negative. That means if we multiply there by negative, all of these is supposed to be multiplied by negative, and this will become a positive now. That means is A12 is 3. Now let's go to A13. Equals to what? We are talking about that position there. That means 2 and 2, 1, negative, and 3 are left. We have 2, 2, 1, 3 are left. Now finding the determinant to that equals to what? 6 minus 2. And remember, the pattern says that is that is negative. That is negative. That means there we are supposed to multiply by negative. We are supposed to multiply by A11, A12, A11, A12, A13. And remember, the pattern says that is positive, and we are supposed that to be positive, and we are left with what? We are left with a 4. Now let's go to the next part. That is A21, and the pattern says that is negative, and the position we are talking is that position that we are left with 1 and 1, and then 3, negative 2. Manipulating that, we are left with negative, inside the brackets we have negative 2. 3 times 1 is negative, is positive 3 minus, and between there we are left with that, and then this negative 6, then we are left with positive 6. That is a 2, 1. Now let's go to a 2, 2. And remember, the pattern says it is positive. That means we are talking about that position. And talking about that position, that means we are left with 1, 1, 1, negative 2. 1, 1, 1, negative 2. So we have negative 2 minus 1. And the pattern that says it is positive, that means we are right. And then this is negative 3. That means the cofactor to that position is negative 3. Now let's go to the position A1, A2, 3. The pattern says it is negative, and that is the position we are talking about. And then we are left with 1, 1, 1, 3. 1, 1, 1, 3. That means there is 3, but remember outside we have a negative, minus 1, and then 2 minus 1 is negative 2, and then that is cofactor to that position. Now let's talk about cofactor of A3, 1. That means we are talking about that position, and the pattern says it is positive. That means it is positive, and we are talking about that position. That is 1, 1, the matrix that is left, a 2 by 2 matrix. 1, 1, 2, negative 1. 1, 1, 2, negative 1. Now manipulating that, we are left with negative 1 minus 2, then it's negative 3, that is 3, 1. And let's talk about A3, 2. That means the pattern says it is negative. Negative of what? Negative of a 2 by 2 matrix. A determinant of a 2 by 2 matrix. That means we are talking about that position, A2, 3. That means we are left with 1, 1, 2, 1, 1, 2, negative 1. Let us assure ourselves. 2, 3, that means 1, 1, 2, negative 1. And then it's negative, negative 1. This and that is minus 2. So we are left with negative 3 inside times that negative, it's positive 3. A2, A3, 2. Now let's go to A3, 3. A3, 3, that means we are talking about the cofactor of that position. And we have that negative 2. That means we are left with 1, 1, 2, 2. 1, 1, 2, 2. Now if we find the determinant to that, that means we are left with 2 minus 2, and that is a 0. That is a 0. Now, my dear students, let's collect the cofactors. Let's collect the cofactors, and then we shall have this matrix. let's start with 1, 1, that is negative 1. Then we have 1, 2, that is 3. Then 1, 3, that is 4. 2, 1, 2, 1, that is 6. 2, 2, that is negative 3. 2, 3, that is negative 2. And then 3, 1, that is negative 3. And then 3, 2, 3, 2 is 3. And 3, 3 is 0. So the cofactors to that matrix is that matrix there. Then the third step, when we are looking for the inverse, we have to find the adjoint. And the adjoint of that matrix, as I called the adjoint of C, will be the transpose matrix of the cofactor matrix. That means the adjoint of a matrix C will be the transpose matrix of that. It will be negative. And remember, the transpose is to exchange the rows to columns and the columns to rows. And then we are left with 6, negative 3, negative 2, negative 3, 3, 0. And then after that, we have to find the inverse to matrix C. And how do we find that? Is we said the inverse of C equals to what? To 1 over the reciprocal of the determinant times the adjoint of C. That means remember the determinant was 6. That means we have 1 over 6. And we have to multiply with this adjoint matrix. Then we have negative 1, 6, negative 3, 3, negative 3, 3, 4, negative 2, 0. So the inverse will be negative 1 over 6. Then 6 and 6 is 1. And then this times 1 over 6 times negative 3 is negative 1 over 2. And then 3 times 1 over 6 is 1 over 2. And then that will be negative 1 over 2. And then that will be 1 over 2. And then this will be 2 over 3. And then there we have negative 1 over 3. And then there we have 0. That means this is the inverse of the matrix C. This is the inverse of the matrix C. Now, after having the inverse, the last step to find the solution to that is to pre-multiply. To pre-multiply the inverse. To pre-multiply. Now, let me pre-multiply that. So is negative 1 over 6, 1. Then we have 1 over 2, negative 1 over 2, positive 1 over 2. That is 2 over 3 at that position. We have negative 1 over 3. And then we have a 0. So we have to multiply with that 1, 1, 1. 2, 2, negative 1, 1, 3, negative 2, and the variables are x, y, and z, equals to pre-multiplication of the inverse. That means it will be negative 1 over 6, 1, negative 1 over 2, 1 over 2, negative 1 over 2, 1 over 2, 2 over 3, negative 1 over 3, 0. And we have to multiply with 3, 0, 15. Now remember, when we are studying the properties of the matrix, that means this is the inverse of the matrix times the matrix itself. The inverse of the matrix times the matrix itself, the answer will be the identity matrix, that is 1, 0, 0, 0, 1, 0, 0, 0, 1. If you take a matrix, let's say a matrix C times its inverse, the answer will be the identity matrix. That means the identity matrix is obtained. That means times the variables. Now let's multiply that side. Negative 1 over 3 times 3. Now let's multiply that side. Negative 1 over 6 times 3, we expect to have negative 1 over 2 plus 1 times 0 is 0, and negative 1 times negative 1 over 2 times 15 is negative 15 over 2. And coming to the second is a half times, that is 3 over 2. A half times 0 is plus 0, and a half times that is positive 15 over 2, and 2 over 3 times 3 is 2. Negative 1 over 3 times 0 is 0, and 0 times 15 is 0. And finding the answers to that, that means if you multiply the identity matrix and that means we shall be left with 1 times x is x, and then the rest will be zeros there, and then there will be left with y, and then the last there will be left with z. And then finding the answers to that part, there will be a negative 16 over 2 is negative 8, that is negative 16 over 2, which is equal to negative 8, and that part will be a negative 18, a positive 18 over 2, that is 9, and that part will be equal to 2. So we have 9 and then we have 2. So my dear students, this is how you obtain the values of the variables when you are told to find the values of the variables by using the matrix method. Then you have to follow the rules and find the answers. Most of the students do find some challenges when they are answering the matrix questions, and the question just say find the value of the variables, just like that. So you are left with the dilemma that can I use Cramer's rule or inverse method? Now when you are told to find the values of the variables by using matrix method, that means you are to use the inverse method. And when you are told to find the values of the variables by the Cramer's rule, then it will be stated that you have to find by the use of Cramer's rule. Now I will leave you some few questions for you to practice more, and find other questions for you to practice more, so that you can be good in this. And some of you students do find challenges, especially in finding the cofactors. They mix the positions of the cofactors. So please don't mix the position of the cofactors. Just use the pattern and write the position as you go on, as we are doing here. The position when we reach A11, we did write the 1, and then after that we collected the cofactors, and then we transposed that, cofactor matrix, and then we follow the rest of the rules, and then we obtain the answers. So please find questions, solve questions. Apart from this, there are a lot of questions out there. So please solve questions, and I assure you, you will be good in matrix. So thank you. Until next time, you were with me, Kimati, from Jangwani Secondary School. Till next time, bye-bye.